by graphing. Let's read it together. 1, 2, 3. I can solve a system of linear equations by graphing. So today we start a new concept, which is system of linear equations. We know what linear equations are, but what is a system of linear equations? Since it's a new concept, you do need your Freyer model, the box, right? Here it goes. So systems of linear equations, what are they? Systems of linear equations are a set of two or more linear equations that have the same variables. Write that down, please. A system of linear equations is a set of two or more linear equations that have the same variable. System of linear equations is a set of two or more linear equations that have the same variable. Copy that, please. Okay, once again, a system of linear equations is a set of two or more linear equations that have the same variable. Let me show you an example. Here it goes. Here's a system. Bracket y equals 3x plus 1 minus 4x plus 2y equals 6. Copy that. Example. Bracket y equals 3x plus 1 and negative 4x plus 2y equals 6. Now, let me see. Yeah, you don't close the bracket. You just show the bracket to indicate that these two belong together. Now, check this out. Let me show you, according to the definition, why this is a system of linear equations. The definition says the set of two or more linear equations. Do we have two or more linear equations here? Yeah, here's 1, here's 2. Therefore, it does qualify so far. However, what is the last thing in the definition? They have to have the same variables. This one has y and x, and this one has x and y. Are they the same type of variable? Yes. That's why this is a system of equations. Let me show you another example. Another way that they write it, they can give you the two equations, but without a bracket. And that's also a system. Check this out. Negative y equals x minus 5, and y equals 2x plus 1. This one is also a system. What do you notice is missing from this one? The little bracket, right? So whenever they say solve the next system, and if they don't give you the bracket, don't worry about it. This is also a system. Now, according to the definition, does it have two or more equations? Yes. Are they the same variables? Yes. Yx, yx, okay? Let me show you another system. Here it goes. Does it have two or more equations? Yes. Do they have the same variable? Yes. Negative 6x plus 3y equals 12, and 4x minus 3y equals 8. Copy those. So now that we know what a system of equation looks like and the definition, now let's look at what it's not. Let me give you one that is not a system. Check this out. Look at this. Y equals 1/2 x minus 2 and 4a plus 2b equals 12. This is not a system. Think about it as you're writing it down. Why would this not be a system of equations? Think about it. Talk it over to the neighbor. Why is this not a system? Okay. So you copied that one. So now let me show you another one that is not an example. Check this out. Look at this. Everybody look up. This one is not an example of a system. Let me move this out of the way. Look at it. Why is this not a system? Don't say it out loud. Why is this not a system of equations? Okay? Talk it over with your neighbor. Why is this not a system? Okay, here we go. So let me get somebody to help me out with that one. Yeah, that's it. So with that said, on the critical attributes here, what is the most important to remember about systems? That they have to be what? Two or more equations, and what else? Same variable. So write that down in there. That's the most important thing to remember about systems. Two or more equations, and they need to have the same variables. Okay, here goes the steps. Here it goes. Step 1, solve for y. Step 1, solve for y. In parentheses, write slope-intercept form. They need to be in slope-intercept form. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph your equations. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Okay, so see if you can, I'm going to give you about 20 seconds to memorize the steps and share them with your neighbor, please. Go. So we got this, right? All right, get yourself your graph paper in front of you, and we're going to start with a big coordinate plane, the one with on the side of the big coordinate plane. At the top of your graph paper, copy example number 1. Here you go. Example 1. Copy this down, please, on the top left of your graph paper. Here it goes. It says, example 1. Solve the system by graphing and check your answer. Yes. System that they give us is the bracket y equals 1/3 x minus 3 and 2x plus y equals 4. Copy that, please. And it should be at the top left of your graph paper. Once again, example 1, solve the system by graphing, check your answer. And the system that they give us is y equals 1/3 x minus 3 and 2x plus y equals 4. Copy that. So I'm going to go ahead and do this one step by step. I need you guys to put your pens down, eyes up here. And when I ask you to copy, you copy. But for right now, just pay attention. Here we go. I'm going to go through the steps. Step 1 said solve for y. So let me look at my equations. Look at the equations. Let's see. Is this one solved for y? Yes, and it's in slope-intercept form. Okay. Look at this one. Is this one solved for y? No. We need to leave y by itself. That means I need to subtract 2x. Subtract 2x. We're left with y equals negative 2x plus 4. Okay. So notice now we both have them solved for y, and they're both in slope-intercept form. Copy that, please. Please. Let me continue. Here it goes. So step 1, solve for y. We did that. Step 2 says graph your equations. I'm going to graph the first one using blue. What information do I need here? I need my y-intercept, which is negative 3. Negative 3 of y. Where's that at? It's right there. And then I'm going to use the slope. The slope tells me to go up 1 step, and how many to the right? 3. So I go 1 up, 1, 2, 3, and I plot my points. And I'm going to do it again. 1 up, 1, 2, 3. And once I have those points, I get my ruler and graph my line. Does everybody see that? Okay, copy that, please. And then I'm going to let you graph the second one by yourself. Go. So you copied this one. I'm going to go ahead and graph the second one in red so you can see the difference. And I'm going to start once again. What information do we need from here? The y-intercept. So we need to look for y4, which is right here. This is my y-axis. Okay. And my slope is right here. My slope says negative 2, but we need to write it in fraction form. So this is 2 steps down and 1 to the right. So I start here. 1, 2, 1 to the right. There it is. Do it again. 1, 2, 1 to the right. There it is. Do it again. 1, 2, 1 to the right. There it is. Do it again. 1, 2, 1 to the right. There it is. And let's graph our line. I'm going to graph that in red. Okay. So, let's see. Step 1, did we solve for y? Step 2, did we graph our equations? Yes. Step 3, identify the point of intersection of the lines. Check this out. Everybody look up to the screen, please. I'm going to use green. By looking up there, can you see where both lines are intersecting? Does everybody see it? So at this point, I want you to identify it by circling it like this. I'm doing it with green so you guys can actually see where it's at. Okay, and right next to it, I'm going to write the coordinate of that point. Let's see, what is my x value? 3. What is my y value? -2. So this point is 3, -2. And let's label that. That is going to be known as our solution. Solution. So the solution to this system is one point. What is that point? The point where both lines intersect. Are we there so far? So let's see. Step 1, solve for y. Yes. Step 2, graph our equations. Yes. Step 3, identify the point of intersection of the lines. Yes. Step 4, check your solution and write a statement. Let me check my solution. Pens down, and then I'll ask you to copy. Here we go. To check my solution is this. According to what I just did, let's see. Does everybody see my red line here? According to my red line, this point is on that red line. Therefore, if I was to substitute those values in here, I would get a number equal to another number which is the same, and it would be true. And you're saying, I don't understand this. Okay, well, check this out. I'm going to first check this one. So I'm going to rewrite this, y equals -2x plus 4. Just pay attention. And what values will I use to check if this is an actual solution for this one? I'm going to use the x value, what? 3, and the y value, -2. So -2 equals -2, and what was x? 3 plus 4. Let's see. So let me simplify. What is -2 times 3? -6 plus 4. I'm going to bring this one down. What is -6 plus 4? -2. Is -2 equal to -2? Yes, this is true. So it is true for that line. Well, guess what? If we are right, look at the blue line. Is this point also part of that blue line? So guess what would happen if I substitute into this equation? It would also be true. Maybe it might not be the same number, but both numbers have to be equal, right? So check this out. I'm going to rewrite this one over here. Y equals 1/3 x minus 3. But instead of x, I'm going to write the number 3. And instead of y, I'm going to write the number -2. I bring everything else down. 1/3 minus 3. What is 3 times 1/3? That is 3 over 3. What is 3 over 3? 1. I'm going to bring down the -3, the equals, and the -2. What is left here? -2. Is -2 equal to -2? Yes, and that is true. So guess what? Since this point is true for both equations, that's why it's the solution to the system. When a point is true for both equations, it's the solution to the system. What is the system? These two equations. Therefore, let's write our statements. The solution to the system is 3, -2. Copy these two where I evaluated both equations and your statement. I'll give you guys some time. Go. Step 1, solve for y. Did we do that? Step 2, graph our equations. Did we do that? Yes. Step 3, identify the point of intersection of the lines. Yes. Step 4, check your solution. I checked it for this one, checked it for this one, and at the end, write a statement. Do we have it? Okay, now you're going to do the next one by yourself. So if you want to use the back side or if you want to use the same side, it's up to you. Just make sure you use a graph that you're not going to get confused. Here we go. Copy this down. Example number 2. Label this one example 2. You don't have to copy the instructions since you already have them. Just copy the system. The system that they give us is y equals x minus 6, and the other one is y plus 1/3 x equal to negative 1. So, think about it. Step 1. Step 1 is to solve for y. Let's see. Is this first one solved for y? Yes. Okay, how about this one? No. So, think about it. To leave y by itself, what do I need to do here? Subtract 1/3 x, subtract 1/3 x. Okay? We're left with y equals negative 1/3 x minus 1. So, step 1 is done. Step 2. What's our step 2? Tell your neighbor, please. Graph. Okay? So help me with this one, please. I'm going to do this one in blue. Help me with this one. Santos, go. Y negative 6. Okay, y negative 6 is right here. And what else do I do? What is it? The what? The slope, right? What is my slope here? 1, and in fraction form is what? 1 over 1. That means 1 step up, 1 to the right. So let's see. 1 step up, 1 to the right. Plot your point. Do it again. 1 step up, 1 to the right. Plot your point. Do it again. 1 step up, 1 to the right. Plot your point. Do it again. Oh, I know. It sounds like a hip-hop song, right? I'm going to call myself DJ Cube. I am. All right. All right, graph that one, please. Here it goes. Here it is. Hey, that's true, right? All right. I'm done with that one. I want you to graph the other one by yourself. Go. Okay, here we go. So, I'm going to graph the second one. I start with my y-intercept, which is negative 1. And my slope says to go down 1 step and 3 to the right. Go down 1, 3 to the right. Do it again. Go down 1, 3 to the right. Let's graph it. I'm going to graph that in red. All right, so it looks like step 1, solve for y, yes. Graph the equations, yes. Step 3, identify the point of intersection of the line. So circle that point right there. Does everybody see the point where they intersect? Right here. All right, so let's see. If I was to estimate the x value, everybody look up, please. It's not at 4, and it's not at 3.5. It's about what? 3.75? 3.7. I want to say 3.75, comma, and what is our y value? 2 1/4, negative 2.25, negative 2.25, and this is what we call the solution. So, check it out, guys. So, if the next step would be to check to see if it's part of that and write your statement, right? Now, the reason I did that step, everybody look up, please. Focus. The reason I wrote that step in, everybody look up, this, where we check it, because the homework's going to ask you to do 2 different things. The homework is going to ask you either to do graph the system and find the solution. So if they ask us to graph the system, do we know how to graph and find the solution? Yes. But what if they ask us to check a point to see if it's part of the solution? They're going to give us the point, and what do? Substitute and see if it works. Does everybody see that? All right, so with that, I want you to copy this next one, please. Copy this one. It says, this is example 3. Example 3. It says, tell whether the ordered pair is a solution of the given system. And they give us the point this time, 5, 2. So they're saying that this might be the solution. But we need to check it, right? Do we know how to check it? Yeah, I need to get this equation. I write it over here, this one over here, and then substitute into both. So therefore, here, let me do this. I'm going to write this one over here. Yeah, you know, technology. I don't know. Here we go. So, and this one over here. And we're going to substitute the x and the y value into both, right? So this one is 5, and I bring down the 2/5 minus, what is y? 2. Let's see, what is 5 times 2? 10 over 5. What is 10 over 5? 2. I bring down the negative 2. Is that equal to 0? Yes. So it's true for this one. Let's check this one. X is 5. Bring down the 3 minus, what is y? 2. 3 times 5 is 15 minus 2 is 13 equal to 13. True. So since it's true also for this one, we write our statement. The solution to the system is 5, 2. Does everybody see that? Why did I write 5, 2? Because we proved now that it is a solution to the system because it works for both. What if it didn't work for one? Therefore, it's not a solution to the system. It has to work for both equations. This one they're not asking to graph. Okay? How we doing? Good? All right. And the last thing, the book's also going to give you a word problem. I want you to look at it and see if you can set it up. Check this out. Before you go, pay attention, please. Focus. Everybody look up, please. Look up. They're going to give you something like this. They say, a video club charges, so video club A charges $5 for membership. So how much do they charge up front? $5. And $3 per movie rental. So $3 per movie, and that's going to give you the amount in dollars, right? The second one, Video Club B, charges $8, and they charge per movie $2 per movie, and that's going to give you the total dollars. So now, do we know how to graph this equation? Start at 5, slope is 3 up, 1 to the right. How about this one? Start at A, 2 up, 1 to the right. And can you find me the point of intersection? Yeah, so the homework for tonight. Homework for tonight is found on page what? Numbers 2 to 16 even. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.